All right, on this lovely day, algebraites, what we're going to be doing is dividing polynomials, but we're going to use a concept called long division. So we're going to go all the way back to 4th grade, and we're going to practice these ones here. Sometimes they're going to end up with a whole number, and sometimes we end up with a remainder. So we'll see what we do with those. So let's take this first puppy here. Remember that this guy here is called the dividend, and the dividend goes inside the division bar. This puppy here is called the divisor because it's doing the dividing, and it is outside. Now, the idea is this. We take the first two numbers here, because this is 2 digits, and we see how many 12s fit inside a 21. And clearly, that's going to be a 1. Only one 12 fits in there. So now we take this 1, multiply this 12, and write the result underneath the 21 here. Now we subtract right here. So I write subtract, and I'm going to bring down 9. Now, of course, we now take this 6 in the 1's place and bring it all the way down. Now I have a new number, 96. And how many 12s go inside of 96? And that will be 8. So 8 times 12 is 96. I subtract those with a 0. So what is my quotient? What's the answer to the division problem? The answer is simply 18. I don't have to write remainder 0. I don't have to write a fraction or a decimal. It's a whole number. So now when we take a gander at this puppy here, this is my dividend, this is my divisor. So 5, 8, 1 is inside, and the 15 is outside. So I ask myself, how many 15s are inside of 58? And the answer to that is 3. So I get 3 times 15 is 45, and I bring down the 13 there. Notice here, the 1 drops down. This one might take a few steps. Maybe you're over here doing 15 times 7, up 15 times 8, or whatever. In the end, we get 8 there. And 15 times 8 is 120. And when we subtract those, I get 11. Now, at this stage, we come to a problem. There are no 15s that can fit inside an 11. So in that case, we're left with a remainder. So this answer is 38, remainder 11. That's one way to write it. So that's one way to write it. The other way to write this is 38, but as a fraction, and we put the divisor as the fraction. So either it's 38 remainder 11, or it's 38 and 11 fifteenths. Again, we're dividing by 15, so that's why the 15 stays down below. We are going to need to write in both of these today as we do polynomials. Now the last problem, let's zip, zip, zip through this one. 22 outside, 253 inside. One of those fit in, so I subtract with a 3, bring down a 3. Only one fits in there, and I subtract that to get an 11. There's my remainder, so my answer is 11 remainder 11, or 11 over 22, which is equal to 11 and 1/2. It's true that 11.5 is the decimal equivalent, but let's keep it in fractions for habit. So we are going to do some long division examples, and we're going to take the algorithm from above and apply it down here to our friends, the polynomials. So this puppy here is my dividend. So this one is going to go inside the division box, bar thing. And this is my divisor, and it is outside. Now here's the key. When we are looking for a number, what we have to do is find a number or letter that makes the first term here look exactly like the first term there. We're going to ignore the 4, the 2, and the 8, all that. All we look at is the first and the first. Okay? So what number times or letter times x gives me x squared? X. And the answer there is x. So I'm going to put that above the linear term there, but technically it really doesn't matter where you put it. Now we have to distribute this x to both of these and write that downstairs. So x times x is x squared.
Minus 4.
And x times negative 4 is negative 4x. Now we draw our line. And what do? Are we adding or subtracting those? Good, so watch the magic here. We're going to subtract everything. Make sure to write that in. We're distributing the negative. The negative is not simply applied to the x squared, but we have to distribute. In other words, we're distributing the subtraction or the negative. And so it was also applied to the negative 4x, now becomes positive 4x. Both are oppositified. Okay, so now we can combine things. What's nice about this is my first term will always drop out. That's the point. So the x squared, okay, bye-bye now. And we bring down the 2x right there. Why? Because 4x minus 2x is 2x. And I'm also going to bring down this negative 8 there. So boop, 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 minus 8.
4 minus 2.
So start the whole algorithm again. What number or letter, or both, multiplies this x to give me this 2x? And it's simply a 2. It's a positive 2, so I put a plus. Now distribute this positive 2. 2 times x is 2x. And 2 times negative 4 is negative 8. Now we have to oppositify both of them down below. And clearly things drop out and I'm left with a 0. So what is the quotient here? My answer when I divide is simply x plus 2. Notice that example B here it's still the same question. It's saying take this polynomial and divide by x plus 1. So let's put our dividend inside the box and put the divisor outside. And I ask myself, how do I get from x to x squared? I need to multiply by x. So I distribute this x to the x and the plus 1. And I get x squared plus x. Of course, I now need to subtract, so I'm going to oppositify everything. Beware, since I have multiple colors, it's easy for me to see right here that it's a subtraction, but you might need to erase or something else. So now the quadratics drop out. The linear comes down as 2x. Boop, 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 boop. And the minus 6 comes down as well. And I ask myself the next question, what number or letter times x gives me 2x? So I say plus 2. So let me distribute that 2 to x plus 2 and oppositify everything. Now, notice that the 2x's drop out and I brought down a negative 8. And at this stage, there is no x variable here. So that means this x can never become an 8 because of the no exponent. So here's my answer. X plus 2, remainder, negative 8. That's one way to write it. The other way to write it is as a fraction. X plus 2 minus 8 over the divisor. And my divisor is x plus 1, so that's downstairs. The remainder is up there. The divisor is downstairs, and this is coming from the top there. Okay, so my dividend goes inside the box. So let's put 4x to the 4th. Now here, pay attention up here real quick, is notice what is not in between here. What's not in between there? Since here, I do not see a cubic term, I am going to write the cubic term, but with the coefficient of 0. So, plus 0x cubed Now I continue with my negative x squared, negative 18x, and plus 8. We'll see why we need to do that in a moment because we're going to end up with some cubic terms that have to be combined with something. And they're going to be combined with the 0.
Should I not write this under the thing?
It depends on how small you can write.
I went up for a little bit.
Okay. Now the algorithm says what number or letter multiplies this x squared to give me 4x to the 4th. So I need a 4, but what's the exponent that I need? I need a 4, an x, and a 2. That is 4x squared. Again, why is that? Because 4x squared times x squared gives me 4x to the 4th power. So I distribute.
I see why we do this.
Now, 4x squared times 2x gives me 8x cubed. So that is why we have to bring in the cube to compensate for this that shows up.
How do you know that at the beginning, though?
I need to finish distributing. So the 4x squared goes to the 3 to give me a 12x squared. Now I draw my line and take the opposite of all 3 terms down below. The quartic term drops out. The negative 8x cubed comes down. And the negative 13x squared comes down. And now I bring down the 18x. So let's make this change real quick. This one here should be a negative 18 because of this right there.
I did.
Can I just do the other one?
Now we start again, and we ask ourselves the same question. What number or letter multiplies the x squared to give me this?
Negative 8.
And it has to be negative 8
X.
and an x.
Woo.
Just kidding, I get it.
Now I distribute the negative 8 across, so I get negative 8 cubed minus 16x squared minus 24x. Draw my line
Then it becomes all.
and oppositify everything. My cubic drops out.
X squared.
I bring down a 3x squared, and I bring down a 6x. So now I bring down this positive 8 to here,
And then you have to go.
and I ask myself the same question. How do I get to a 3x squared from here? It's just simply 3.
It's just 3, sweetie pie.
Now distribute the 3x squared plus 6x plus 9. Now I have to oppositify everything. Notice the quadratic drops out, the linear drops out, and I'm left with negative 1. And that is my remainder. So the actual answer is this. My quotient is 4x squared minus 8x plus 3, remainder negative 1. Or 4x squared minus 8x plus 3 minus 1 over x squared plus 2x plus 3. And there we go.